Afternoon. So we're going to do the 2020 paper. All right, so starting, I'm not working every paper. I'm not working all the questions. Question 1, it's on thermometric titration. The reaction is between hydrochloric acid and magnesium metal. So you know that acid and metal, that is an exothermic reaction. And in an exothermic reaction, the temperature is going to increase. So some information from the question. Laptop is freezing. All right, so ready again. And the question, it gave us the concentration and volume of the acid. We have the volume of the acid, we have the concentration, we have the mass of the magnesium metal. How it would work, we have the container with the acid, you record the initial temperature, then you add the magnesium metal, and you record the temperature. So from that, we have the temperature readings here. Scroll down to the table. So in this table, we have the time in seconds and temperature. And we are supposed to complete the table. Give me a second. All right, so from when we read the temperatures, as you can see, you would read go up. So 30, 31, 32, 33. This is halfway between 39 and 40, so it would be 39.5. 43, 43.5, and 46. That was 33, 39.5, 43, 46, 45.5. Right? So the temperature would increase and then it decrease up. And they're asking us to plot a graph. Already have the grid for the graph, so we will just plot the figures. For the first reading, it was 0 for the time and 25 for the temperature. So that was the first reading. The second one, time of 15 seconds to 33 degrees Celsius. 1, 2, 3. And then 45, 43, 45 seconds. About here. One is about rough estimate. And 75 to 46, 90 to 45. All right, so we draw a best fit curve. Probably something like about this. All right, so let's go. So the graph would look like that. And they ask from the graph, record the, what was it, the highest? User graph determine the temperature change. So the temperature change, it would be the highest temperature minus the lowest temperature. So the lowest temperature, it would be the 33. And the highest temperature, it would have been the 46.5. They use the lowest temperature and the highest one. And so I'm going to erase that. Right, one difference between an endothermic and exothermic reaction. For endo, there will be an increase, there will be a decrease in temperature. And for exo, the temperature. So once the temperature increase, it is exothermic. Once it decrease, it is endothermic. And next one, the container in an exothermic reaction will get hot. The one in the endothermic, the one in the endothermic reaction, it will get cold. So here it says state whether the reaction is exothermic or endothermic. So we know it is exo. As I had explained, once the temperature increase, it is an exothermic reaction. And it asks for a balance equation. Magnesium reacts with hydrochloric acid solution. When acid and metal give salt and water. We'll get plus hydrogen gas. I'm going to put it down here. In terms of balancing, you will need a 2 in front of hydrogen. And it says calculate the number of moles of magnesium used in the reaction. So in the information portion of the question, we had used 0.48 gram of magnesium. So mole equals to 0.48 gram. This was provided in the question. And they give us the relative atomic mass, which is 24 gram per mole. Gram cancel gram. Number of moles is 0.02. And it says determine this is the 2022, by the way. Determine the volume of gas that would be collected if it took place at STB. Volume of gas here it would be hydrogen gas. So you have to use the mole of magnesium to get the mole of hydrogen. So you're going to use mole ratio. Mole ratio between magnesium and hydrogen is 1:1. Therefore, the mole hydrogen equal to 0.02 mole. Volume of hydrogen. You're working in cm cube, you will use 22,400. You want to work in dm cube, would be 22.4. And so volume of hydrogen is equal to mole times ST. It would be 0.02. I'm going to work with the 22,400. You should get 448 cm cube. Give me a second. All right, so moving on. As it says, calculate the energy change for the reaction between magnesium and hydrochloric acid. So the formula for that is Q is equal to MC delta T. For the M is not the mass of magnesium, it's actually the volume of the acid. So whatever volume you get, that is what you will use for M. And in the question was 100 cm cube hydrochloric acid. So it's 100 times 4.2 times the temperature change, we got to be 16.5. So delta T is the change in temperature we calculated earlier. C is the specific heat capacity, which is 4.2. So 100 times 4.2 times 0.5, that's 6,930. Now it's an exothermic reaction, so I'm going to put a negative sign in front of it. So the negative sign, because it is exothermic. So negative sign to indicate it's an exothermic reaction. And then it says determine the energy change per mole. Whenever you want it per mole, you're going to just divide this answer again, which is 6,930. 6,930 divided by the mole you had already calculated, which was 0.02. Right? So it's the energy from whatever answer you get from Q equal MC delta T, you divide it by the mole. Right? Okay. 346,500 joule per mole, but you actually put the answer in kilojoule. So from kilojoule, or to convert joule to kilojoule, you divide by 1,000. So if you divide this answer by 1,000, you will get 346.5 kilojoule per mole. Remember, it's exothermic, so you put a negative sign in front of it. And so that's how you would work it out. Down to question 3. So this is organic chemistry. It says take the whole molecular series to which compound A and B, well, to which compound A belongs. So this is the functional group for a carboxylic acid. The functional group of compound A, that's the carboxyl group. The name of compound A, carboxylic acids, they end in anoic. And it has 1, 2, 3, 4 carbons. So it is butanoic acid. State whether compound A will undergo a condensation or an addition polymerization reaction with alcohol. Right, so in terms of addition, only alkenes undergo addition polymerization. For addition polymerization, only alkenes. The compound A, which is a carboxylic acid, it will undergo condensation. So just like in esterification, carboxylic acid and alcohol, that's a condensation reaction. So answer is condensation. Take the whole molecular series to which compound B belongs, and write the functional group and the name of compound. Let's just look back at compound B. This right here is the functional group. So the functional group, carbon to carbon, double bond. It's an alkene. For the whole molecular series, it's an alkene. The name of it, 4 carbon. It is butene, but the double bond is between carbons 1 and 2. You start counting from the end closest to the double bond. If between carbon 1 and 2, you could either say 1 but, or you could say but 1 e. So this is the name of the compound. This is the homologous series. And this is the functional group. Moving on again. For the functional group, homologous series. The structural isomers. All right, ready again. So structural isomers are compounds, same molecular formula, but different and structural formula. The same molecular formula, but different structural formula. Now this is pentane, of course. And you should know that so the molecular formula of this compound is C5H12, and it has 3 isomers. And the straight chain form, that is 1 isomer. So this pentane, that is 1 isomer. And they're asking us to draw the fully discrete structures of 2 isomers of compounds. All right, so let me just draw back. I'm just going to draw the carbons here. The pentane has 1, 2, 3, 4, 5 carbons. So want an isomer, move the carbon from the end, that would leave you with 4 carbons. 1, 2, 3, 4. This carbon that you are taking off, do not put it at the end. Put it on a carbon between the end carbon. So you could put it here. Right? Of course, you have to put on your hydrogen. Then, if you want the next isomer, you will take off a carbon again from the end. That leaves you with 3 carbons in the chain. Remember, you cannot put any carbons at the end. So this one, this CH3 group, and this CH3 group is, if you were asked to name them, This is our main chain. It has in 4 carbons. It is butane. When you have a CH3 group that is not a part of the chain, it is methyl. It is on carbon 2, methyl butane. This chain has the 3 carbons. It is propane. You have a CH3 group above, CH3 group below. So again, a CH3 group is called methyl. Because you have 2 of them, it is dimethyl. Both of them are on carbon 2, so it is 2,2 dimethyl propane. So these are 2 more isomers. Straight chain up top is 1. So we have a total of 3 isomers for pentane. Butane has 2. Right, so again, moving on. Name isomer 1 and 2. All right, so we did that. All right, we have electrolysis. So it says figure 5 shows a line diagram representing the electrolytic cell using the electrolysis of aqueous copper sulfate using, importantly, copper electrodes. You have active electrodes and you have inert electrodes. Once you're using metals as your electrodes, it is active. You are using graphite and or platinum. These are the 2 electrodes that we consider inert, right? They do not react. So the active ones will actually react. So the fact that you are not using graphite or platinum means it is an active electrode. State whether the electrode is active or inert. Active. By react, at the anode it will be oxidized. Lose electron and is oxidized. So it's active, it is actually going to take part. So after a while, it will break down piece by piece. Right? It's actually losing its atoms over time. Describe what occurs at the cathode and the anode in an electrolytic cell. So we know that at the anode, oxidation occurs. For the anode, electrons migrate from anode to cathode. It's not, it says describe what occurs at the anode and cathode in an, so it's not referring to this specifically. All right, so generally electrons move from anode to cathode, and then anions in solution or in the electrolyte, anions in electrolyte move to the anode and are oxidized. And at the cathode, cations move to the cathode and are reduced. So cations in the electrolyte move to the cathode and are reduced. Remember, the cathode is your negative electrode, so the positive ions, which are the cations, will migrate to it and gain electrons, which is why they are reduced. Finished, it will automatically be on the channel. Yes, so it's just click on the channel, click on live, and you will see the live sessions. Once it's end, it will be there. All right. Moving on. It's a state which electrode in figure 5 is the cathode and the anode. All right, what was A, what was B? So positive electrode is the anode, negative is the cathode, which means that A is anode and B is cathode. Identify the ions that will migrate to cathode and anode. It's a solution of copper sulfate. Once it is a solution, all right, so ions at the cathode, you will have the copper ions from the copper sulfate. But remember, it's a solution, so you're going to have hydrogen ions from water. You're going to have Cu2 plus and SO2 4 2 minus from copper sulfate. And you're going to have H plus and OH minus from the water. Now, the two positive ions will move to the cathode, and the two negative ones will move to the anode. The hydroxide and this will move to the anode. Then it says, write half equations to show the substances produced at the cathode and the anode. All right, normally, if it's an inert electrode, which means it does not take part in any reaction, it would be the ions in the electrolyte that would either be oxidized or reduced. But because we're using an active electrode, it's not the hydroxide ion, the sulfate ion, or the hydrogen ions that you're going to write the half equation for. So at the anode, we know that oxidation occurs, but it's not the sulfate or the hydroxide ion that is going to be oxidized. It's going to be the copper electrode. So they're going to have oxidation of the copper. So in this setup, it's just like the purification of copper. Right? So it's basically like the purification of copper. So the copper metal, that is the electrode, this is why it is active. It is going to be oxidized. Copper ions, which will fall into the solution. Do not leave out a state stables. So you have oxidation occurring. Now at the cathode, these copper ions are going to migrate to the cathode. Where they are reduced. Remember, reduction is the gain of electron. So at the anode, you would have the formation of copper ions, and at the cathode, copper atoms. But using your answer in part B2, which is these two of equations, explain why a redox reaction took place during the electrolysis of copper sulfate. So a redox, all right, so before I write it, at the anode, oxidation is taking place. At the cathode, it is reduction. So a redox reaction is one in which both oxidation and reduction take place. So once you have both reduction and oxidation taking place, that is a redox reaction. Redox reaction occurs both oxidation and reduction occurs. Copper atom was oxidized at anode and plus ions reduced this cathode. Both oxidation and reduction occurs. Suggest one change that is likely to be observed. So again, this is similar to the purification of copper. So they should happen to ask you about the purification of copper. These are the same equations and observations that would be involved. So the anode is going to get thin or it break down, and the cathode, it would get thick. One change at the anode. Anode will get thin, whichever synonym you want to use. So if you want to say it will get thin, or decrease in mass, or size, whichever. Right? Or if you want to say it will break down, whichever one you want. All right, so it says explain how the electrolytic cell can be modified to plate copper onto a piece of steel. So this process is what they're asking you to describe here is called electroplating. All right. Remember, all right, so for electroplating, You have your container with this solution. Quickly, I'm going to use a different example. I am going to plate silver onto copper. If I want to plate silver onto copper, my anode is going to be silver metal. So plate silver onto copper, my anode is going to be silver, and my cathode is going to be copper. And my electrolyte is going to be a solution with silver ions. For example, silver nitrate solution. So in electroplating, whatever you want to plate, whatever you are using to coat the next metal, you put it at the anode. Whatever is to be plated, so copper is to be plated. Whatever is to be plated, you put it at the cathode. Whatever is doing the plating goes at the anode. And the electrolyte must contain ions of the metal that is doing the plating, in this case, silver. What is going to happen? Silver is a metal, which means it is an active electrode. So the silver atom is going to be oxidized to give silver ions. So this is what will happen at the anode, just like above with copper. Anode. Then at the cathode, right, silver ions. So the silver ions in solution, they migrate to the cathode, and they will be reduced to silver atoms. They are not going to be in solution. They are going to stick to the surface of copper. And that is how it will cover the surface of copper. Right? So, back to the question, explain how this cell can be modified to plate copper onto a small piece of steel. Very simple. Only modification that is needed is at the cathode, you will replace copper with steel. So the cathode, the anode will stay as is, copper metal. But the anode, it is going to be steel. The cathode is going to be made of steel. Right? You replace copper, with at the cathode. Cu2 plus ions will migrate the cathode. And get used copper atom, which sticks the surface of steel. They stick to the surface, that's how they coat the surface of the metal. So this process they're asking about is electroplating. If you happen to join the class late, it is 2022 June. All right, so we're going to move on again. All right, organic chemistry again. So it says state 4 general characteristics of a homologous series. So members of a homologous series of the same general formula same functional group similar chemical properties. Each successive member differs by H2. Those are 4 properties. Question 2, write the general formula of the alcohol's homologous series and the molecular formula of the 5th member of the homologous series. So the general formula for alcohol, CnH2n plus 1 OH. Remember, N is the amount of carbons. So of the 5th member, it would have 5 carbons. So it would be C5H times 5 plus 1 OH. 2 5s 10, 10 and 1 is 11. C5 H11 OH. Right? But the molecular formula, right, it groups the elements together. So it would be C5, carry this hydrogen and it to this 11. So it would be C5H12O. Molecular formula, you group all the elements together. So it becomes C5H12O, not C5H11OA. Clear our drawings. And so here we have a compound. Says circle any 2 functional group. The easiest functional group that students overlook is that of alkanes. I'm going to circle it first. Any carbon to carbon single bond, that's a functional group. That's alkane. We have carbon to carbon double bond, that's alkene. Of COOH, that's carboxylic acid. This bond here, that's ester. Ester, carboxyl, that is for alkene. That's for alkane. This is for carboxylic. So we have 4 functional groups. And moving on. All right, so experiments were conducted were carried out on two hydrocarbon gas samples, E and F, to determine which gas is ethane and which gas is eth. And we have the results. Hydrocarbon E, it changed bromine water from orange to colorless. And hydrocarbon F, no reaction. It says state the difference between alkanes and alkenes. Well, the major difference, alkanes are saturated. That is all the carbon atoms compound on single bonds. Or single bonds. Okay? Alkenes are unsaturated, which means they contain carbon to carbon double bond. Alkanes are unsaturated, alkanes are saturated, and alkenes are unsaturated. Using the observation in table 4, I identify hydrocarbon E and F. The one that decolorizes the bromine is alkene. Hydrocarbon E is ethene. Hydrocarbon F, alkane. Right? And this is the condition under which an alkene would react. UV light. Right? If I want to put some light. So the reason why no reaction occurred didn't have any UV light present. If UV light was there, a reaction would occur. By the way, the name of this reaction is halogenation. You should know the name of your reactions and the conditions. All right, Jones. So it says, write a balanced chemical equation including state symbols for the burning of ethene in gas, in air. They could have equally asked you for the name of this reaction once it's burning, is combustion. Ethene, that's C2H4, a gas with a state symbol. A combustion, we are burning the hydrocarbon in oxygen gas. Right? Product of combustion is carbon dioxide and water. Did not mention if the oxygen is. Good day, will you post this, sir? Yes, once it ends, it will automatically be on the channel. So just click on, click on lives. Just go in the video section of it and click on live, and you will see it. All right, C2H4 plus oxygen, right? So they did not say if the oxygen was insufficient or sufficient. So we assume the oxygen supply was sufficient. So it is complete combustion. If they had mentioned that the oxygen supply was low, it would have been incomplete combustion. And if it was incomplete, you would have got carbon monoxide. But when it is complete, you are going to get carbon dioxide. Right? So we are doing complete combustion. All we need to do is balance the equation. So for combustion, once it's complete, carbon dioxide and water, products are not changing. It doesn't matter the hydrocarbon. You must get carbon dioxide and water. All you have to do from that or from there on is to balance the equation. And then you start with carbon. Any amount of carbon that is in your hydrocarbon, you put it in front of CO2. We have 2 here, C2, so you put a 2 in front. Any amount of hydrogen in hydrocarbon, divide it by 2. And so you get, put it in front of water. When it comes to oxygen now, please remember to multiply the number in front by the amount of oxygen. So 2 2s, that's 4, plus 2 1s, that's 2. That's a total of 6. Whatever number you put here will be multiplied by 2. So 6 divided by 2 is 3. You put a 3 in front. 3 2s, 6. If you had gotten an odd number for oxygen, like 7, 9, 5, 3, just put it over 2. When it comes to oxygen, if you get an odd number, just simply put it over 2. And that's it. That being 3 over 2, 5 over 2, 7 over 2, 9 over 2. Reason being, 9 over 2, that's 4.5. We don't write 4, we don't use a decimal in balancing the equation. So you could use an improper fraction, which is 4.5. But we tend to use improper fraction, which is 9 over 2. So that is where I say, once you get an odd number, putting it over 2, convert it to an improper fraction. And it works out. So 9 over 2 is 4.5. 4.5 times 2, 9. Right? And that is it. Alright, I'm not doing any green chemistry. So I'm going to end this session here. I'm going to look for a question with rates of reaction and come back in about 10 minutes or so and work it. All right, so this was from 2022. Right, I'm going to end this session here. 10 to 15 minutes time, I'm going to work a question with rates and a little more organic chemistry. Right, so you can just check back the channel by 5:05 in that time. Again, this will automatically be on the channel. So I'm ending it here.